Everyone give the heading. Part 2, Chapter 11, Eccentric Loading. Guys, everyone give the heading. Part 2, Chapter 11, Eccentric Loading with the help of red pen, everyone. Now, what is meant by eccentric loading? We will try to understand the scenario here, everyone. So now we will deal with, first of all, we will take one basic example, guys. Consider it is like a basic example one. We are going to deal with that one. Suppose we have one short column is there. Compulsory short column is there, guys. No long column. Otherwise, it goes in a buckling, guys. So here we have what? A short column is there. Observe, here we have what, everyone? This is what a short column. Now try to understand. We are going to understand the meaning of what, guys, everyone? Eccentric loading. Everyone observe. So now, so this is what a short column. So here we have what, guys, everyone? Short column is there. Everyone observe. Now what this line indicate, guys, everyone? This line indicate what? Center line of the column. Everyone try to understand my important point. What I want to explain. 1 minute. Let me make it straight. So here what? This is what our center line of what, guys, everyone? Center line of the column. And this column is what, guys, everyone? Short column. So this is what a center line of the column. Everyone. Bigger line. Smaller line. Bigger line, smaller line, bigger line, smaller line. Try to see the scenario, guys, here everyone. So this is what a center line. Now what is the meaning of C? We have till now we studied main 3 types of stresses, guys. Everyone, before going further, I want to tell you one important thing, guys. Till now we have studied totally what, guys, everyone? Total 3 types of stresses. What we have studied, guys? Total 3 types of stresses. First is what? Direct stress. First is what? Direct stress. Direct stress means what? Suppose this is what our column. Just imagine that. I will explain you. This is what our column. Observe. This is what a column. It is fixed at what? Suppose at the bottom end. And here, this is what a center line of the column. Just this is a rough drawing, guys, everyone. And exactly at the center line, a concentrated load is going to add, and that concentrated load is what? F. So due to this F, what is going to happen? Stress is going to generate, and that stress we will say it as a direct stress, and we denote that one as a sigma D. There we denote by sigma, but here we will denote by what, guys? Sigma D, and that sigma D will be equal to what, guys, everyone? Force by area. And suppose this column has a circular cross section. Just imagine that. This column has a what, guys? Circular cross section. Then this value of stress is same everywhere. Means if you consider any point here, any point, value of this sigma D, direct stress, same, guys. Is it the same everywhere? It is same here. It is same. It is same everywhere on this cross section. Because we always represent stresses with respect to cross section. Remember, guys. So direct stress is same. After that, we have seen second type of stress. We have seen, guys, what? Bending stress. We have seen shear stress also, but shear stress is not that much important. Then we have seen what, guys, everyone? The next important is what? Bending stress. Now what, guys, everyone? So what is there, guys, everyone? Bending stress, guys, everyone. So here we have what, guys, everyone? Bending stress is there. So now bending stress will be what scenario? In case of the bending, see here compression is there. If you apply instead of this force like this, 1 minute, guys. So here, suppose here we can apply a force like this also. In this case, in case of compression, we will have what, guys? Tension. So here we can apply F like this also. We can apply F like this also. If you are applying F like this, tension. If you are applying F like this, compression. Now try to see the scenario, guys. Next point, bending stress. We are going to consider this same column. Now everyone observe. the difference between direct stress and bending stress and what is going to happen. Try to understand the scenario, guys, because next thing is a combination of direct stress and what, guys, everyone? Bending stress. See, here this is what our column. This is what everyone center line. Everyone center line of the column. Here, just imagine that it can be any cross section, guys. Just for a simplicity, now I am showing circular, guys. So just imagine that this is circular cross section. Let me draw it properly. Circular cross section. This is the rough drawing, guys, everyone. So this is what a circular cross section. And this cross section, see, as here, in case of the bending, guys, how will be the load going to act? See, till now,
side loads.
See, perpendicular to the, guys, means earlier which things we have seen? Beam is like this, everyone. Our beam is like this. If you remember, suppose just cantilever beam, just we have seen in last chapter, guys, everyone. And this is what our everyone load. Just we turn that one by 90 degree. If here remember, this is what a cross section. This will become what? Neutral axis. Now in this scenario, neutral axis will become what, guys, everyone? This one will become neutral vertically. Everyone getting my point? So this is what our neutral axis. Now, but here if you observe, in this case, bending stress is going to what here on neutral axis? What is the value of bending stress, guys? Everyone tell me. On this neutral axis, bending stress is what?
0.
0. Bending stress is what? 0. At this point, we will have what, guys, everyone? Maximum compressive bending stress, guys. Because this is going to bend like this. If it is going to bend like this one, this compressive maximum compressive bending stress. And here what we will have, guys, everyone?
Maximum tensile.
We studied these things, just now. Earlier we studied considering this as a horizontal. Now we are considering this as a what? Vertical. Only that.
Vertical.
So maximum tensile bending stress. So here we will have a maximum tensile bending stress. And here bending stress is going to vary throughout. Means what? Here maximum, here 0, maximum tensile to 0, then 0 to maximum compressive, guys. So bending stress is very throughout this one, guys. Everyone. But suppose we consider this is some one line. On this line, if you consider any point, guys, suppose you consider any point on this line, if you consider this point, any point on this line, our bending stress is what, guys? Will be same, guys. Because what is the relation for bending stress? It is, see, guys, basic. Elizabeth Rani, may I find you? So F means what? M by I into Y. If at the same distance from a neutral axis, so this will be what? This case, this will become what, guys, everyone? Y. Try to see the scenario, guys. Why I am explaining you all these things? Because we need now in upcoming discussion. See, here force, guys, observe. In case of the direct stress, force is what, guys, everyone? In case of the direct stress, everyone, force along the center line. In case of the bending stress, force is perpendicular to the center line. Now the combination is what, guys, everyone? Now try to see the scenario here. This basic example one, everyone observe. Now the force is not along the center line, not maybe perpendicular also possible, but I am taking basic example. So here everyone try to see the scenario here. So now here eccentric loading. Force is not along the center line, little bit away from the center line. 1 minute. So here we will have what, guys, everyone? Observe. So this is what, guys, everyone? A force. And this force is what? What we will say? This is what? An eccentric load. It is a concentrated load, but it is away from what? Center line. It is away from what, guys, everyone? Center line. And its distance from a center line will be what, guys? 1 minute. I will show that distance. Observe this green one, guys, everyone. Observe this green one. This distance is nothing but the distance between line of action of force F and center line. This is the center line, guys. Distance from neutral axis we will show on the column, guys. Remember, don't get confused with the center line and neutral axis. Neutral axis always on the cross section. Center line always on the column or beam. On the column or beam. Everyone, see the scenario. So this distance between F and center line will be what, guys, everyone? We will show it as a what? Small e. Small e means what, guys, everyone? What is the meaning of small e? Small e stand for what? Eccentricity. What will we say, guys? Small e? Eccentricity. You may have heard this term in mathematics, guys. Eccentricity. What is the meaning of small e, everyone? Small e stand for what? Eccentricity. It is what, guys, everyone? Distance between line of action of force. Line of action means what? What is the meaning of this one, guys? This is the line of action of force F. Line of action of what, guys, everyone? Line of action of force and center line. Everyone got the meaning of E? E stand for what? Eccentricity, and it is distance between what, guys, everyone? Line of action of force and what? Center line. And guys, you should be familiar with all these terminologies. Everyone. And what this denote, guys, everyone? This is mean by what, everyone? This is denote what, guys, everyone? Tell me. Center line of the column. So this is what our center line. So now everyone got it, center line. So now here this F is what, guys, everyone? Tell me. Eccentric load. Guys, what this F? Eccentric load. It is not along the center line. If it is along the center line, then direct stress. Now because of this F, guys, what is going to happen? 1 minute. Because of this F, there are two things going to happen, guys. Because of this F, what is going to happen? There are two things going to happen, guys. Because of this F, everyone, because of this F, there are two things are going to happen. What are the two things, guys, everyone? First of all, what, guys? Guys, due to this F, this column is going to what, guys? Compress. Column is going to compress. Along with compression, it is going to bend. Means because of this eccentric load F, what are the things going to happen? There is a compression of the column, and second thing is what, guys? Bending of the column. Everyone, due to eccentric load F, guys, everyone try to listen my words carefully. Due to eccentric load F, due to what, guys, everyone? Due to eccentric load F, following two things. Following two things going to happen. Two things takes place. Guys, these are the just rough wordings, guys, everyone. Due to eccentric load, following two things takes place. What is first thing, guys, everyone? Tell me. Compression of the column. Compression. Guys, everyone, try to see the scenario. Compression of the column, everyone. What is the meaning of compression? Compression stand for what, guys? What is the meaning of? Decrease in length of the column. What is the meaning of word compression? Compression of the column means what? It means decreasing length of the column. Guys, say if you are not getting any wording, anything, guys, everyone, please feel free to ask me. Decreasing length of the column. And second thing is what? Bending of the column. And what is meant by bending, guys, everyone? Bending means what? Because of this F. See, guys, I am drawing one figure, rough figure. Column is going to bend like this, everyone. So this is meant by what, guys, everyone? Bending of the column. Everyone got it? Now here, everyone try to understand the scenario. We are discussing very, very important concept, guys. See, in this chapter, you can't memorize anything. Only you need what? You need only two things. Which two things you need? Direct stress means what? F by A. And bending stress means what? F max. Maximum bending stress will be equal to what? M by I into Y max. And one more extra thing. It is from the basic theory video. Components of a force. Components of a force. Other than that, we don't need anything. Everything is here logic based. You can't memorize anything in this chapter, guys. And every time you may get a new questions also, guys. Every time you may get a also. So here you can't memorize. So now everyone observe. Don't write anything, don't do anything. So now due to this compression of the column, what is going to happen, guys? Everyone, 1 minute. Don't write anything. So first of all, due to this compression of the column, compression means it means decrease in length of the column. Due to this direct stress, is going to develop. Due to this, what is going to happen, guys? Direct stress is going to develop. Direct stress is going to develop on the what, guys? On the cross section. Guys, remember, stresses always acts on what? Cross section. Guys, stresses. So due to this, direct stress is going to develop on the what, guys? Cross section. Everyone. So see the scenario, guys. This is a F. This F is going to what, guys? Everyone. It is going to what, guys? Everyone. This F is going to what? Is going to what? Compress the column. Everyone, try to see the scenario here. So because of that, direct stress is going to develop. Due to this compression of the column, what is going to happen? So what is going to happen, guys? Whenever there is a decrease in length, due to this, direct stress is going to develop on the cross section, guys. And what is the direct stress here, guys? Everyone, what is the direct stress? Everyone, try to see the scenario. That direct stress is what, guys? Sigma D, and sigma D will be equal to what, guys? Everyone, force by area, and it will be in what, guys? Everyone, Newton per meter square, and its nature is what, guys? In this case, compression. In this case, nature is what? Compression. We will take another basic example too. In that case, instead of showing up here compression, we will show you tensile. We will see that basic example too in the next lecture, guys. Don't worry. So now try to see the scenario here, guys. Everyone, don't write anything. Just try to understand my point. So this is what sigma D stand for what, guys? Direct stress. So due to this, direct stress is going to develop on the cross section, and that sigma D. Now the next important thing is what, guys? Everyone, don't write anything. Let me first of all complete few things. So now it means a decrease in length of the column. Due to this, direct stress is going to develop on the cross section. So now this direct stress is same everywhere on the cross section. This direct stress, guys, this point is very, very important. This direct stress, guys, everyone, this direct stress, what? Sigma D is same everywhere, on the what, guys? Everyone, on the cross section of the column. On the cross section of the what, guys? Everyone, column. Everyone, try to understand this sigma D. Now what is cross section? Everyone, 1 minute. Try to understand my point. Why I am explaining you all these things, everyone? 1 minute. What I am going to do? I am going to draw one dotted line from here. Everyone, observe this dotted line, because we have not shown it. We are saying cross section, but still till now we have not shown any cross section. So everyone, so this is dotted line, this is a dotted line. Everyone, observe, everyone. And now what we are going to show? Cross section of the column. Everyone, observe. So this is what, guys? Everyone, a cross section. You can consider any cross section here, guys. Everyone, but for a simplicity, we are showing a cross section. What, guys? Everyone, circular cross section. Generally columns are generally circular, but it is not necessary it is circular. It can be rectangular also, it can be I shape also, guys. We will see in our upcoming discussion which columns we will have and how to build that one. So this is what a circular cross section. So here just we will consider 3 points. Suppose point A here, just imagine that. What we are going to consider? We are going to consider 3 points. Point A, then we will have what, guys? Everyone, so this is the center point, point B, and then point C. Here what we have, guys, everyone? 3 points are there. Point A, point B, point C. So we have 3 points. So now if you observe, stress is what, guys, everyone? Direct stress is same everywhere. At point A also direct stress same. Point B also direct stress is same. Point C also direct stress is same. Everyone listen my points here. Direct stress is same at every point. Direct stress is what, guys, everyone? Is the same at every point. So now try to see the scenario here. Now then next. So two things going to happen. Due to eccentric load, two things going to happen. First thing is what? Compression of the column. Due to compression of the column, direct stress is going to develop on the cross section, and that direct stress will be equal to what? F by A. And here nature is what, guys? Compressive. Now this direct stress is same everywhere on the cross section. Now second thing is what? Bending of the column. And due to bending, guys, everyone, try to understand this point. Due to what, guys, everyone? Due to bending, bending stress, due to bending stress is going to develop. Due to bending stress is going to develop on what, guys, everyone? On the cross section of the column, guys. I told you we always mention stresses with respect to what, guys, everyone? Cross section. So due to bending stresses is going to develop on the cross section of the column, everyone. And bending stresses is not same everywhere on the cross section. Bending stress is not same everyone. Try to understand the same point. Bending stress is not same everywhere, everyone. Is not same everywhere on the cross section of the column. Observe the thing here, guys. Bending stress is not same everywhere on the cross section of the column. Means what, guys? Here observe. Try to see this drawing, everyone. If you observe this drawing, guys, everyone, observe the scenario here. Now at this A point, or on this view, this is what A point, this is what a B point, this is what a C point on this view of the column. On the cross section view, this is what. Now everyone, one more thing. On this column, on this cross section view, what this line indicate, guys, everyone, tell me? No. Center line is on what? On the view of the column. And on the same line, if you extend the same line further, the same line will become what, guys, everyone? Tell me. This line
Center.
is neutral axis, guys.
Neutral axis. Yes.
And what is the speciality of neutral axis, guys? Guys, bending moment is not a zero.
Bending
Stress.
stress
Bending
Stress is
stress
zero.
is zero, guys. So on a neutral axis, what is the speciality? Why we are giving that axis as a neutral axis, guys? At that axis, bending stress is what, guys? Zero. Everyone, try to understand my point. So from here to here, this distance will be what, guys, everyone? Guys, one important thing. E is a different thing, Y max is a different thing. E can be anywhere. It is varies from 0 to Y max. E is a different one. Y max is what? Distance of outer fiber from what? Neutral axis.
to neutral axis.
Not a center line. Don't say center line. Distance of outer fiber from the neutral axis. Guys, that is the meaning of Y max. We have studied this one, guys, everyone. Now, everyone, what we discuss, guys, bending stress is not same everywhere. Here, guys, everyone, 1 minute. I will show here. Observe. Here, bending stress is what, guys, at point B? Bending stress is what? 0. Bending stress is 0. Guys, everyone, bending stress is what? 0. At point C, guys, everyone, tell me. At point C, everyone, observe. At point C here, on this view or on this view. This is what a point C we can show. At point C, guys, everyone, tell me. On point C, guys, everyone, tell me which type of bending stress we will have? Maximum tensile or maximum compressive in this?
Maximum compressive.
Maximum compressive bending stress in this case, because our column is going to bend like this, so this side we will have a compression, everyone. So maximum compressive bending stress. Now at point A, guys, everyone, tell me, at point A, everyone, observe.
Maximum tensile bending stresses.
1 minute, this is what a point A. So at a point A, guys, everyone, tell me maximum, guys, at point A, maximum
tensile bending.
Maximum tensile bending stress. Now, guys, if you remember our discussion, this cross section is what, guys, everyone? The given cross section is what? Symmetrical about neutral axis. What is the meaning of symmetrical about neutral axis? Here, see, earlier neutral axis. Earlier neutral axis is what, guys, everyone? Horizontal. So we earlier, if you remember our discussion from the previous chapter, earlier neutral axis is what, guys? Just observe this question. Earlier neutral axis is what? Horizontal. So portion above the neutral axis and portion below the neutral axis, they are what? Mirror image of each other. Now in this case, what we can conclude, guys, here in this case, neutral axis is in this case vertical. On this view, neutral axis is what? Vertical. This is a view, guys. Actually neutral axis is horizontal only, but on this view it looks like a vertical. Means if you observe, guys, if you observe 3-dimensional drawing, 1 minute, you will get a more understanding with the help of 3-dimensional drawing. I will draw one 3-dimensional drawing. Just imagine that this is what our 3-dimensional drawing, everyone. See, just imagine that this is what our neutral axis, everyone. So this neutral axis is again horizontal only, guys. Horizontal line. But on that view, means if you know third angle projection method, guys, then this top view will become what? Everyone. Guys, everyone. So this is a first angle, not third angle. So top view will become at the bottom. So here what is going to happen? If you turn that one, guys, if you turn that one, so it looks like vertical. Everyone, getting a point? Try to see the scenario here. So now everyone observe the things here carefully, what we have to do and how we are going to approach the things further. So now, as it is a symmetrical about neutral axis, it means what? Maximum tensile bending stress and maximum compressive bending stress. Both value will become what, guys, everyone? We will denote only by what? F max. Though it is a why same? Why same, guys, everyone? Why same, everyone? Why same? Maximum tensile bending stress and maximum compressive bending stress. Why is it the same here?
Why max is same?
Because our cross section is what, guys? This cross section is what? Symmetrical about neutral axis. So this side y max and this side y max, both side outer fiber at the same distance from a neutral axis. So f max from this side and x max from this side will be what, guys, everyone? Same. So for this chapter, guys, everyone, what will be the scenario? So bending stress is not same everywhere on the cross section, and maximum bending stress will be what, guys? F max will be what? M by I into what, guys, everyone? So this is what a maximum bending stress. Guys, 1 minute. So now before going further, everyone, give the heading basic example 1. Everyone, before going further, give the heading basic example 1. And draw this figure properly, guys, everyone.
Sir, we need to write that F max comma C and F max comma T.
No need to write down, only F max, sir. Or you can say, 1 minute. Guys, 1 minute. So if you don't want to get confused, so here we will say 1 minute, guys. F max comma C, we will make it as a what, guys, everyone? F max C is equal to what, guys, everyone? We will say only F max C equal to, okay, 1 minute, 1 minute, guys, my mistake. So here, so F max comma T, we will say simply F max for this case, everyone. And then this one, guys, everyone, this F max comma C will be equal to what, guys, everyone? F max, because both the same here. Now start writing down these things, everyone. The remaining discussion, guys. Everyone start writing down this discussion. Now, guys, everyone, second point, bending of the column. Everyone write down this discussion. 1 minute, guys, before writing the second point. 1 minute. Everyone, before writing the second point, listen my words carefully. Is not semi-variable on the cross section. Maximum bending stress is at what, guys, everyone? Maximum bending stress is at the, guys, where we will have, is at the,
at a distance of E.
Is at the maximum distance. Maximum distance from where, everyone? Maximum distance from what?
Neutral axis.
Maximum
Neutral
distance
axis
from
of
neutral axis. Distance from where? From neutral axis, guys. Everyone, maximum distance from neutral axis. So everyone write down quickly. So now everyone try to see the scenario. Therefore,
Okay.
Net stress at each point is a combination of what? Therefore, net stress at each point. 1 minute, guys. Net stress at each point is a combination of what? Is a combination of what, guys, everyone?
Direct stress plus
Is combination of what?
ball bending.
Is combination of direct stress.
Yes.
Is combination of what, guys, everyone? Direct stress and bending stress. Everyone. Net stress at each point is a combination of what? Direct stress and bending stress. Everyone try to see the scenario. So therefore, everyone, net stress at point A. Guys, observe. Net stress at what, guys, everyone? Point A. Observe the point A. So we will say net stress at point A is what? Sigma A. So observe this one. At point A, we will have two stresses. One is what? Direct stress. And another is what? Bending stress. One is a direct stress. Direct stress is same everywhere. At point A, point B, point C. Here also direct stress, here also direct stress, and here also direct stress. What is the nature of direct stress, guys? We have everyone compressive. And nature of bending stress at point A will be what, guys, everyone? Tell me. What is the nature of bending stress at point A? Tensile. So then one is a tensile, another one is compressive. So then net stress will be what, guys? Difference of that two. Guys, so here we will have two scenario. If, guys, 1 minute. So net stress at point A we can write down in two way. If in one scenario, if F max, guys, 1 minute. So if F max greater than sigma d. Then net stress at point A will be equal to what? F max minus sigma d, and nature will be what, guys, everyone? Tensile. Because at point A, bending stress is of what? Tensile in nature. So F max minus sigma d. So this is a one scenario. Everyone try to see the scenario for point A. This is one scenario. In second scenario, guys, everyone, if guys, in second scenario, what we can say? If direct stress is greater than F max, then net stress at point A will be what, guys, everyone? Direct stress minus F max, and nature will be what, guys, everyone?
Compressive.
Compressive. Everyone getting my point? Try to see the scenario here. Very, very important discussion we are doing. So this is what a net stress at what, guys, everyone? Point A. Everyone getting my point? Try to see the scenario here. The next thing will be what, guys? Net stress at what? Next point will be what? Net stress point B. And guys, if you observe at point B, which type of stress we have, guys, everyone? At point B, only direct stress. Only what, guys? At point B, no bending stress.
Only direct stress.
Only by direct. So sigma B will be what, guys, everyone? Sigma D. And nature of direct stress is what, guys? Compressive.
Compressive.
So here, so this is what a net stress at what, guys, everyone? Point B. Then everyone, net stress. 1 minute, guys. Yeah. At point B, I am not written at. Net stress at what, guys, everyone? Point C. Now, guys, everyone, if you go to the point C, what is, guys, at point C, guys? I told you every point we will have a bending and direct. Now, direct stress nature is what? Point C? Compressive. Bending stress is also compressive. Compressive. We have to add more compressive. So then, net stress at point C will be what, guys, everyone? Sigma D, direct stress, plus what, guys, everyone? F max. And net effect is what, guys, everyone? Tell me. Compressive.
Compressive.
Guys, you are getting my point. So that's why from the beginning only we are trying to understand the nature, guys. If you want to add two stresses, then their nature must be same. If natures are different, higher value minus lower value, and nature will be what? Higher value nature. Start writing down the discussion. Then, guys, everyone write down this one: net stress at point B and net stress at point C.